Okay, shall we go through the first one at least? Make sure we're all okay with the first one. Okay. So we have two pairs of vectors here. We have u is 3, 8, 2, and we have v is 8, 1, 0. And I have asked you to calculate the angle between these two vectors. So in other words, if that's u and that's v, my two hands as one vector, what's the angle between those two vectors? Okay, that's the question. So, are you happy that this is just really the formula that we need? And I proved this to you on Wednesday. Okay, it's just purely the cosine rule applied to vectors. So we've got three things we need to find. We've got the dot product of a and b, and we've got the length of a and the length of b that we need to find. So in this case, my vectors are u and v. So I need, first of all, the dot product of them. Okay, so what would the dot product of u and v be? How would I calculate it?
To add the squares of this I.
That's finding the length. So how do I find the dot product?
It's uv multiplied by vu, no?
So I'm looking at this times this. I'm multiplying corresponding elements together. So this times this, so 3 times 8, added to the y components multiplied together, so 8 by 1, added to the z components, if you like, added together, so 2 multiplied by 0. And if I do that, what does it come out as? 32, hopefully.
32.
Good, excellent. Okay, so then what is the length of u? What is the length of u? So this is, Rashid, what you were saying here.
Yeah.
So it's going to be the squares of the lengths, the squares of the components added together, then square rooted. So it's just Pythagoras applied to 3 dimensions. So it's going to be 3 squared plus 8 squared plus 2 squared. Okay? Did we get an answer for this?
77.
Yep, okay, that looks reasonable. So square root 77, yeah? And the length of v, what's that going to be equal to?
Root of 65.
Okay, so it's the same kind of idea. You take 8 squared, 1 squared, and 0 squared, add them together, take the square root, and we get the square root of 65. Good. And you just put all of those 3 pieces into the puzzle, into this thing. Okay, so cosine of theta then is going to be equal to a dot b, so the dot product of my 2 vectors, divided by the product of the lengths. So root 77 multiplied by root 65. And I can see Benazir typing away on her calculator. What's theta going to be equal to then?
63.5.
63.1 degrees. Perfect. Are we all happy with that? Are there any questions there? Good. Okay. What about this one? Have we all had a go at this one? Yeah? Okay. So how are we going to go about doing this? So what's a dot b?
17.
Good. So you just need to be careful here because it's not in column notation. But that's okay. I think we can manage it. So let's do the i's. So 6 multiplied by 3. And then the j's. Well, there's no j over here, but we still need to include it. It's just 0. So 0 multiplied by negative 4. Added to the k's, which is negative 1 multiplied by 1. Okay, so just the components multiplied together and then added. Okay, so we get here 17? Yep. Okay, in which case then, how do we calculate the length of A? Can anybody tell me? Good, so what would it be? Square root of?
37.
Oh, yeah, so 0 squared plus negative 1 squared, good. So 6 squared plus negative 1 squared is going to make the square root of 37. We all happy? Okay, and in which case then the length of B is going to be equal to that thing squared plus that thing squared plus that thing squared square rooted, which comes out as 26? Square root 26. Okay, and that's the easiest bit done. Okay, well, that's the hardest bit done, I should say. The easy bit now is just to stick it into the formula. Okay, so I have cosine of theta will be equal to the dot product divided by the products of the lengths. So root 37 multiplied by root 26 Stick all that in your calculator. You remember to find theta, you need to take the cos inverse of all of this. So what I would do is do it in stages. I'd stick that in your calculator first, you'll get an answer, and then to find theta, just simply type cos inverse, which remember is shift cos on your calculator, answer equals, and you get an answer of 56.8 degrees. Are there any questions about that? Any queries? Is that all good? Can we move on from vectors now? Good, fantastic.